Hi, this is Skid Kelly, and I'm here at Potter's Place in Andover, New Hampshire, on a section of the Northern Rail Trail. I'm here today to introduce my video on gear ratios. Just like the sprockets of my bicycle, gear ratios will let your robot's motor change its output.
Let's use this simple gear setup to illustrate the principles of gear ratios. We have a 12-tooth gear and a 36-tooth gear. Notice that we have placed a small line on each one of these teeth so we can keep track of how far the gear tooth has gone around. Gear ratios consist of a driving gear and a driven gear. In this case, we are going to drive the 12-tooth gear, and the 36-tooth gear is going to be driven. Let's see what happens as we start them turning around. We'll give the 12-tooth gear one complete revolution. Now notice that the 36-tooth gear has only moved 1/3 its distance around. We actually have to turn the 12-tooth gear 2 more times before the gear teeth lock into one another. This is known as a 3-to-1 gear ratio because the driving gear needs to go around 3 times before the driven gear has gone around once. You will notice in the 3-to-1 gear ratio, the 12-tooth gear, which is the driving gear, goes around 3 times as fast as the 36-tooth gear, which is the driven gear. That means anything which is attached to the driven shaft will receive 3 times the amount of torque that is being applied to the driving shaft. Now let's see what happens when we reverse the gear ratio. This time we will be driving the 36-tooth gear, and the 12-tooth gear will be our driven gear. Let's put 1 revolution on our driving gear. And notice the driven gear, in this case, has gone around 3 times. So this is known as a 1-to-3 gear ratio. If we drive the 36-tooth gear and let the 12-tooth gear be driven, notice that now the 12-tooth gear goes around 3 times as fast. Anything which is attached to the shaft of the 12-tooth gear, the driven gear, will spin 3 times as fast, but it will only receive 1/3 of the torque that is applied to the driving gear. Let's see what happens when we have a compound gear ratio. In this case here, we have a 12-tooth gear driving a 36-tooth gear, and on the same shaft there is another 12-tooth gear which will in turn drive the output 36-tooth gear. As we turn the 12-tooth gear 1 complete revolution, notice our driven 36-tooth gear has traveled 1/3 the way around, but our output gear has only traveled 1/9 the distance around. This giving us a gear ratio of 9-to-1 because the driving gear needs to go around 9 times before the driven gear goes around once. With the 9-to-1 gear ratio, this compound gear setup means that the output is only moving at 1/9 the speed of the input. So there are 9 times the amount of torque being applied to the output shaft as there is to the input shaft of the motor. Compound gear ratio. The output shaft is spinning 9 times the speed of the input shaft. Although this greatly increases the speed of the output shaft, the torque applied to that shaft is only 1/9 the amount of torque that's being supplied by the motor at the driving shaft.